Hello and welcome to another video on applied electronics. I'm going to be solving quiz 1 for petroleum engineering students. So this is quiz 1 for group 1 of petroleum engineering students. Now we are going to start right away. So we have quiz 1. So let me make some changes here. So this is PE for petroleum engineering. Okay. Now, so the first question we have state 4 properties of an insulator. So this one I've already explained this um, in one of the videos, right? I think chemical engineering students uh, video I explain properties of an insulator. So you can go pause and then go and watch the properties of an insulator in that video. So I'm not going to be talking about that in this video. We have also 1B with the aid of diagrams explain barrier potential. So this one I'm going to explain barrier potential. Now, when we talk about barrier potential, we are talking about the energy needed to overcome the electric field that is being created on the PN junction as a result of the migration of electrons into the P region. So what tends to happen is that before even the PN junction is being formed, you have to take a semiconductor and then you dope one part of the semiconductor. So for example, you have a semiconductor here. One part of it, you dope it with P-type impurities, right? So here you have P-type impurities. So you have majority holes as a result in the P region. And you have minority electrons. So we have minority electrons. And then you dope the other part, the other half of the semiconductor is being doped with N-type impurities. So we end up having majority electrons. So we have majority electrons and then minority holes. So we have some minority holes. So this represents the electrons and this one represents the hole. Okay. So what is going to happen is that because the N region, they are having majority electrons. So these electrons will start to migrate or diffuse across the PN junction. So this is what we refer to as the PN junction. This thin layer that is separating the two regions. That is the P region and then the N region. So the electrons here are going to start to migrate or diffuse across the PN junction into the N region. So because electrons are leaving the N region, you end up creating a positive ion on the you will end up creating a positive ions near the p-n junction where the electrons are located. So where the electrons are, once they leave, you end up you get a positive ion. So another electron is going to migrate, you'll get another positive ion. But now because the p-n region is accepting these electrons, so that means they are gaining electrons in that sense. So you have negative charge there on the n region. On the p region side, you have negative ions there, right? So now you end up having positive ions on one side and negative ions on the other side. So these positive and negative ions, they also have charges, right? So the positive ions, they tend to have positive charges, while the negative ions, they have negative charges. So as a result of this, there's going to be an electric field. Once you have a charge, once you even have only one charge, you have what? An electric field around that charge. So imagine if you have a lot of ions in this along the p-n junction. So you have electric field. And this kind of electric field, which is formed as a result of what? The positive and negative ions, we refer to as an electrostatic field. So this electrostatic field that we have here, we have the ions here. So the electrostatic field will now block electrons from moving into the p region because of what? The force that is now existing between the ions along the p-n junction. So the electrons can no longer move into the p region. Now the energy that is required to overcome the electric field, which we refer to as a barrier in that sense, right? It's like you have a wall that is preventing electrons from entering into the p region. So the energy that is needed to overcome or break the electric field is what we refer to as barrier potential, right? So you need some amount of energy or force in order to break through the barrier that is separating the two regions. Now, the next question is, so question 2A, state 3 ways of connecting a bipolar junction transistor. Illustrate the connection with diagrams. So this question is the same question that was given to refining engineering students. So we have the first group, meaning RP162A. So I'm not going to solve this one. Then we have 2B, explain how NP and bipolar junction transistor work. So the same question is also there. So you go and watch the video on this, on the explanation of NP and bipolar junction transistors. Now, question 3, what is rectification? So rectification is the process of obtaining a unidirectional waveform. So as a result of this, we are able to convert an alternating current into a direct current. So what do we mean by unidirectional waveform? What that means is that you want to make sure that the output waveform is only in one direction. So the direction here is talking about the positive, right? And then the negative, this alternation. So we want to make sure that either we having only positive alternation throughout or only negative alternation. But when it comes to direct current, in that sense, so when we are rectifying, when the signal is being rectified, we tend to be focusing on only the positive alternation so that we have only that one. So that's what we mean by rectification. Now, what is the load current and the peak load voltage if the diode is ideal? Okay, so this question is similar to that of RP162 group A. So let me try and then calculate this. So we have this question. Yeah, so for ideal diode. Okay. Yes, so I think this is the same question, so I'm not going to calculate this. So go and watch on the solution for refining engineering students group A, right? Group A. So this is the end of this video on quiz one of petroleum engineering students. See you in the next video.